Section 9.8 is a topic called completing the square, and as you can see here, the goal is to create a perfect square trinomial. So just like in 9.7, we want that perfect square situation so that we can square root and solve our quadratic. So now I'm going to show you this example just based off of an expression. Just remember that we're going to be working with equations where it's normal to add things in, whereas with an expression, normally you don't want to add in anything or anything like that. But here's what completing the square looks like. We're actually going to use b over 2 to the second power. Sorry, that looks like a 6 kind of. That's a b. So remember, we're set up with ax squared plus bx plus c. And usually that equals 0. So as I had mentioned, you don't usually take an expression and add things to it, but just for showing you how to complete the square and create a perfect square trinomial, I'll show you what I'm talking about here. So in this example, b is 10. So in my little formula here, I'd go 10 over 2, and we would square it. And 10 over 2 is 5, and 5 to the second is 25. So normally if this was an equation, we would add 25 to one side and 25 to the other side. You'll see what that's going to look like. Just for the purposes of showing you how this turns it into a perfect square trinomial, this factors into x plus 5 times x plus 5, or x plus 5 to the second power. Okay? And like I said, that's going to be helpful because as you saw in 9.7, we can take the square root of that. So here are kind of the instructions when you're trying to solve a quadratic by completing the square. First, you need an equation. And this will all make sense once we go over some examples. But your equation needs to be in this form. So a, in your ax squared plus bx equals c, a has to equal 1, meaning there is no number out in front of x squared, just 1. So if it's, well, you'll see what that looks like. We may have to divide everything by something to make it that way. And then you want your constant, or c, on the right side of your equation. So we'll see what that looks like as well. Second step is find that b over 2 to the second power. Add that to both sides in step 3 of your equation. We factor, we square root, and we solve. So again, you can come back to this chart and look at it afterwards, but let's see what it looks like with some examples. So if they asked us to complete the square with these, and again, you can factor these and solve any way you want. It's just that sometimes completing the square is a better route. Okay, so that's all I'm going to show you, but just know that you can factor different ways and get the same answers. So here, my b is negative 2. And I'm going to divide that by 2 and square it. Negative 2 over 2 is negative 1. And if we square negative 1, we get positive 1. So what I'm going to do is add 1 to both sides of my equation. And we have to do that to keep them equal. So this turns into x squared minus 2x plus 1. And now I'm going to also add 1 to 2, giving me 3. The left side factors into x minus 1 times x minus 1, or x minus 1 to the second power. And then what we can do here is square root to solve. So just remember that when we square root, we got to consider the positive and negative value. 3, square root of 3 is going to be an irrational number. These cancel, and I'm left with x minus 1 equals that. So we would get an irrational answer here. Your two cases, x minus 1 equals positive square root of 3, and case 2, x minus 1 equals negative square root of 3. You could get the decimal. You'd have to approximate, but one thing you could do here is just leave it as x equals square root of 3 plus 1. And then on this side, negative square root of 3 plus 1 would be your other answer. So those are the irrational answers. Okay, so that's how we would use completing the square. On the right here, we have an example of what happens when c is on the left side. We want to push that over to the right. So I would have to add 3 to both sides. And now we have 2x squared plus 5x equals 3. We have a couple other another issue here. We don't want a to be bigger than 1. We need it to be 1, so we have to divide everything by 2. And we're going to get some decimals doing this, but it's okay. So x squared plus, and I'm going to go 2.5x equals 1.5. So this is going to get a little bit different, because now I'm going to have to erase this here. Oops. I'm going to have to, when I use my formula here, b is 2.5. So I'm going to have to go 2.5 divided by 2 to the second power. And if we do that, if we do 2.5 divided by 2, we get 1.25. And then if we square that, we get 1.5625. Which is what we're going to add to both sides of the equation. So x squared plus 2.5x, here we'll use a different color, plus 1.5625 equals, I'm just going to do 1.5 plus that and see what we get. 3.0625. Oops. Okay, so this is not your typical trinomial, but it is a perfect square trinomial. That's one thing we do know. So it's going to be x plus something. So I'm going to take the square root of that 1.5625 and see what we get here. 1.25. We know that that's going to be squared, and it's going to equal my 3.0625. And then what we can do is from here square root both sides, remembering that we're going to have a plus minus situation. These will cancel. We'll have x plus 1.25 equals plus or minus. Now if I take the square root of 3.0625, we will get 1.75. So even though we had some weird decimals, it's actually working out pretty nicely here. So let's see if I can extend my screen. There we go. And we'll just finish this off. Okay. If we consider our first case, x plus 1.25 equals positive 1.75. And then our second case would be x plus 1.25 equals negative 1.75. And we could solve these and we would be good. So basically what we're going to find out here is just a quick little subtraction here. Looks like we're going to get 0.5. So x could be 0.5 or 1/2. And over here, we get negative 3. And there we go. So that's one where completing the square got a little messy, but it also would have been extremely messy trying to do it any other way as well. So it's up to you, right? Sorry, so that one took a while, but I wanted you to see one that was a little bit more challenging. I'm not going to go through this example, but one thing I just want to point out is this one actually has a no solution. And the reason it does is because after you complete the square and everything, you get down to something like x plus y squared equals negative 1. And we can't square root a negative number, so that's why this has no solution. Basically all that means is your parabola does not cross the x-axis. So sorry, this one took me a little bit longer, but I wanted to make sure I got some good examples in there for you.